Hello everybody, today we are doing Unit 12. It's about 3D shapes and finding surface area and volume. Before we can dig into that type of math, we need to learn some properties of solids. So what I have here on this slide is I have polyhedras and some shapes that are not polyhedras. I want you to take a minute, you can even pause the video, and I want you to look at the differences between the two. So now that you've taken time to look at the difference, what I want to point out is on polyhedras, all the faces, all the sides of the shape are polygons. So if I take a look at this cube, everything, all the sides are going to be squares, which is a polygon. It's a four-sided polygon. Over here on this pyramid, the base is a square, it's a polygon, and then the, sides, the lateral sides are all triangles, which is a three-sided polygon. And then if we take a look down here, this solid shape has a pentagon as one of the sides, which is a five-sided polygon, and it also has rectangles, which is a four-sided polygon. So polyhedras, all sides are made out of polygons. That's what makes a polyhedra. Our not polyhedral shapes have circles as part of their sides. Circles are not polygons because they don't have sides. They're a continuous curve. Even the sphere has a circle, so it is not a polyhedron. So let's dive a little deeper into polyhedras and their parts. So the first thing I want to point out are the vertex, or the vertices. It's just the corners of the shape. It's where three or more edges intersect. I'm writing on a room, so INTs for intersect. So all these little corners here are vertices. Because three or more edges intersect at that point. Next thing I want to go over is the edges. An edge is a segment created by two faces intersecting. Sorry, I'm running out of room. Okay, so all of these edge pieces here those are all edges. And maybe you want to label it edge. Again, if I go too fast or you need time to draw that diagram, you can pause the video. Next, we're going to talk about faces. Faces are the sides of the 3D shape. Okay, it's any polygon in the polyhedra. Okay, so like down here, this is a side, this square piece. And then like up here, this square piece, those are faces. But it can be even the squares around laterally, around the edges vertically. Okay, so that's a face. And then last, we have bases. Bases are always faces, but faces do not have to be bases. know that seems like a lot, but they're always faces, but faces don't have to be bases. Okay, so the purple that I put on there as faces are actually the bases of the polyhedra. And they're also the bases. What I mean by the faces don't have to be the bases is over here there's a face on this side. It is not the base because it is not the top or the bottom of the polyhedra, but it is a face of the polyhedra because it's still a square. Remember, it just has to be a polygon to be a face. So when we do surface area and volume, we're going to come across two different types of shapes. One of them is a prism and the other one is a pyramid. We're going to talk about the differences of a prism and pyramid. I'm going to write down the formal differences and then I'm going to show you how I identify them. So first, a prism looks like this and a pyramid looks like that. In a prism, the bases are going to be congruent and parallel. Okay, so bases are congruent and parallel. Okay, that's what makes it a prism. In a pyramid, there's only one base. Okay, so for me, I know a shape is a pyramid because I take a look and I only have one base and everything else comes up to a point. So if it comes up to a point and only has one base, I know it's going to be a pyramid. When I try to identify if it's a prism, I look at the base, and the cool thing about this is this base, if you move it up to the top, it's what's creating this 3D solid. So if the base, if you move it straight up and it creates that rectangular prism, what we have here, it's going to be a prism because this base is congruent to this base, the top and the bottom, and they're parallel. So that's the difference between a prism and a pyramid. So let's name some shapes. Okay, so I already named the first one. It's a rectangular prism because if I look at the base, it is a rectangle, and it's a prism because it is, let me try that again. Again, it's a rectangular prism because the base is a rectangle, and if I look at the other base, it's going to be equal. So this is a rectangular prism. If I look at my next shape, again, if I'm going too fast and you need to draw the diagrams, you can pause the video, draw them down, and then continue. This I already know is a pyramid because it goes to a point and it only has one base. We use the bases, if you've noticed, we're going to use the bases to name it. So this base is a triangle and it goes to one point, so it's a pyramid. So it's a triangular pyramid. Okay, so again, we look at the base first and then we determine if it's pyramid or prism. This base has 5 sides. So it's a pentagonal pyramid. It's not easy to say. And it's a pyramid because it goes to a point. Sorry if my writing is bad. I'm doing this from home on my Chromebook. It's not the best, but it's what I have. All right, and next, now this cannot be my base. The reason this can't be my base is because if I move it up, it neither comes to a point or is an equal base. Because it doesn't come to a point. If you look here, it actually comes to an edge. It's different than here. So that's how I know that that rectangle on the bottom is not my base. But if I take a look here, I have a pentagon. And if I move it through this way, these two pentagons are going to be my bases, and they're congruent. So this is a pentagonal prism. Oh, sorry guys, I don't know why that happened. Okay. And then last but not least, I have a rectangle down here, or a square, I don't really know, so the broader term would be rectangle, and it goes to a point. So this is a rectangular pyramid. If I knew that that was a square on the bottom, it would have a different name. All right. The next thing I'd like to talk about is what is a regular polyhedra. A regular polyhedra means that all the faces are congruent and all the edges are congruent to each other. Okay, so think of like a regular polygon was that all the angles and all the side lengths were equal. In a regular polyhedra, it's going to make all the faces and edges congruent to each other. And essentially what that just means is that all polygon faces are congruent. So all the polygons are congruent. Having the polygon faces congruent just results in the faces and edges being congruent. And if the faces are polygons and they're congruent to each other, that means the sides and the angles are congruent. So keep that in mind. So over here on my diagram, I can mark it up, saying that this is congruent to that, and then these are all congruent as well. Okay, so all those edges are going to be congruent. All right, one last thing that I need to go over, and then we can be done, is Euler's formula. Euler's formula is face plus vertice minus edge. No matter what the polyhedra looks like, is always going to equal 2. Okay, that is a pattern that Euler found, that when you take the face, add it to the vertices, and subtract the edges, you will get 2 every time. Okay, so you might want to write down that, this is for face, number of faces. Number of vertices. And number of edges. Okay. So if I had a problem, how you'll see this in our classroom is me giving you problems like this. Use Euler's formula to calculate how many faces a polyhedron has if it has 20 edges and 10 vertices. So I know that this is my v variable, and 20 edges is going to be my e variable. So when I set this up, I'll have faces plus my vertices, which is 10, minus my edges, which are 20. And that all has to equal 2. And I just solve for f, combine like terms, and I get negative 20, or negative 10, sorry, equals 2. And then I add 10 over, and I get 12. So I have 12 faces. So the last thing is just a little formula that can help us, without having a diagram, figure out how many faces or how many vertices or how many edges depending on the given information.